are you? I think all are rocking. Okay, today I have taken topic introduction to limits, and in introduction to limit we will study meaning of x tends to a and then limit of function, and we will try to find out the limit of algebraic functions. Let's see meaning of x tends to a. Let me tell you what is the meaning of x tends to a. Firstly, what is your x here and what is your a here. Let x be a variable. I have made here circle. X be a variable. X is a variable, and a be a constant number. So what do you mean by the variable here? X can take up the values, right? X can take any value, and a be a constant number, and a is constant, fixed number. Fixed number. If x takes a value such that the numerical difference between x and a is sufficiently small, then we say that x tends to a. Then we can say x tends to a, or instead of this we can say x approaches a, or we can say x approaches a and is written as x tends to a. In this form we can write down, and we can read, okay, x tends to a or x approaches a. Clear everybody? I think, okay, clear. X, once again let me repeat, okay, x is a variable here, means x can take any value near to a, and a is a constant number which is a fixed number which cannot be moved from here and there. Okay, then if numerical difference between x and a is sufficiently small, then we can say x approaches a. Let me explain this numerical difference. Okay, suppose here x numerical difference means x minus a or a minus x, right? Only just we will count the numerical difference, not the sign. If suppose, okay, instead of this I'm going to take, okay, x and tends to 1. What is the meaning of this one? Means x approaches 1. Let's suppose, okay, x is just value which is very near to 1, and it may be x, okay, maybe your 0.99, and if we find out the difference between 1 and 0.9, you're gonna get here 1 minus 0.99 is equal to 0.11. Yes, 9110. All right, you will get 0.11. If you find out the 0.99 minus 1, then you will get, okay, minus 0.11. But numerical difference means only this, you can say only just numerical difference means only we will count 0.11. We will not pay attention to a sign. That is for the numerical difference, and to get the numerical difference we use modulus sign, and modulus sign, after using modulus sign you will get 1. So you can find out the difference, either 1 minus, you can do 1 minus 0.99, or you can do 0.99 minus 1, but you need to use mod, then only you will get the numerical difference. All right, numerical difference between x and a is sufficiently small, then we can say your x tends to a. So let me tell you again, okay, if we have a x tends to a, x tends to, instead of x tends to a, if we take, okay, x tends to 1. So what is the meaning of x tends to 1? According to this, if difference between x and 1 is sufficiently small, x is a variable, 1 is your constant. Here x can take any value, like, okay, 0 point, let's suppose, okay, 0 0.5, 0 0.8, 0 0.9, 0 0.99, 9, and so on, right? But x is not equal to 1. X is very near to 1, x approaches 1, but it can't be 1. Alright, so this is the meaning of x tends to 1. Listen to me here, everyone. X can not only just can take the value from left of 1, okay, x can take the value from right. Let's go firstly. on the number line diagram. Here, okay, you can see in number line diagram I have a made, okay, a is a constant I have a made, and x is a variable, here, okay, I have made, okay, x, here arrow, okay, yes, on right side, okay, and here I have made, okay, arrow, okay, to left side of x, okay. This means, okay, x is approaching a from left side of a, and x is approaching from right side of a. This means, okay, here x tends to 1 means not only, okay, x can take the value 0 0.5, 0 0.8, 0 0.8, 0 0.9, 0 0.99. Okay, x can take the value like this way, 1.5, 1 point, okay, your x may be 1.5, 1.2, 1.1, or 1.01, 1.001, so on, okay, but very near to 1, okay. Here also we can x tends to 1, okay, here, and if we see this data so from here we can say x tends to 1. And if we see this data, here also x tends to 1, but what is the difference between them? Here x approaches from left of 1, and here x approaches from right of 1, right? So I think x tends to a is clear, means simply you can memorize, you can just keep in your brain only one thing, x numerical difference between x and a is sufficiently small, then we can say x tends to a. If numerical difference between x and 1 is sufficiently small, then we can say x tends to 1. If numerical difference between x and 2 is sufficiently small, then we can say x tends to 2. Okay, now let's move into the limit of a function, right? So before that, uh, let me erase all these things. I'm going to expunging all these things. Here limit x tends to a, this is clear. Before going into this diagram, let me take one example for limit of function. Let's say, let me take, okay, let f of x is equal to x squared minus 1 upon x minus 1. Very simple example I have taken. If you want to find out the value of function, okay, at x is equal to 1, f of x you will get, okay, x is equal and 1 square minus 1 upon 1 minus 1, 0 upon 0. As I have discussed already, this is your indeterminate form, okay, the meaningless form, and you can say indeterminate form, 0 upon 0, meaningless. Okay, numerator is 0, denominator is also 0, then you can say the indeterminate form, meaningless form. Okay, there is a no any numeric value for this form. Okay, so from here we can say we can find out the value of a function at x is equal to 1. Value function. Sometimes, okay, what the students do, let me tell you, mistake, okay. If we have to find out the at x is equal to 1, and some students try to find out like this way. Firstly they simplify the function like this way, x square minus 1, x minus 1, they factorize the numerator, and they cancel out this term, and x plus 1, and try to write down f of 1 is equal to 1 plus 1 is equal to 2. This is not correct for at x is equal to 1. Wrong. Absolutely wrong. Why is wrong? Why we can't do? When we have to find out the value function at x is equal to 1. Here you can see this factor. Okay, if you see this one, x minus 1, x plus 1 upon x minus 1. At x is equal to 1, you have, okay, 0 into 2 upon 0. So 0 upon 0 you can't cancel out. Okay, 0 upon 0 you can't cancel out. That's why this is wrong. Okay, right? You can't cancel out, okay, 0 upon 0 you can't cut like this way. If you do like this way, then this shows, okay, you are doing, okay, this way, so which is not possible, okay. So I think it's clear, okay. And if for x is not equal to 1, then only f of x square minus 1, x minus 1 can be written in this form. Okay, x minus 1, x plus 1 upon x plus 1, sorry, here x minus 1, and you can cancel out x plus 1. If your value of x is not equal to 1, then you can write f of x, okay, is equal to x square minus 1 whole over x minus 1. If you simplify, it's gonna come, okay, x plus 1, right, x plus 1. If x is not equal to 1, if x is equal to 1, then you will get 0 upon 0. Okay, so this means, okay, from this example is clear, we can find out the value of function. Value of function is undefined, okay, absolutely undefined. You are not getting any numerical value. Okay, let's say then what we can find out. Can we find out, okay, limit here? Can we find out, okay, value of function if x approaches 1? All right, okay. If here, if we take, okay, x tends to 1, can we find out? Then let's see, okay. Let me make, okay, here x tends to 1, and here f of x, or here again, let me make, okay, x tends to 1, and here f of x. F of x means x square minus 1 upon x minus 1. F of x is x square minus 1 upon x minus 1. Okay. Let's suppose here x, okay, left of x is taking value left of 1, and here x is x can take the value from right of 1, right of 1. So let's suppose here x is approaching from left of 1, and right x approaches 1 from right. Okay, here I'm choosing left of 1 means 0 0.5, 0 0.8, 0 0.9, or 0 0.99, 0 0.99. X is variable, x is moving, a 0 0.999, and so on, 99, and so on, 99. Okay, and so on. Now, all right. And if we find out, okay, value here by using calculator, you can 1.5, 1.8, 1.9, and 1.99, and 1.99, and here 1.99, so 99, and 99, so again, okay, so on, right? So here x approaches 1 from left, x tends to 1, x is going to very near to 1, and okay, and here if we observe this value of function is also near to 2. If 1.5, 1.8, 1.9, as we make here difference between x and 1 sufficiently small, here also you are getting, okay, one number, okay, one fixed number whose difference between f of x is going to be sufficiently small, and you can say we can make difference between f of x and the number which will come here can be made very small as we wish by making difference between x and 1 sufficiently small. Now let's see, if we see, okay, this x approaches 1, and here so from here x tends to 1 as we have written here, and then here f of x, okay, tends to 2, right? So it can't be 1, it can't be 2, it can't cross, okay, as you will take, okay, near to 1, okay, 0 0.99999, you are gonna get here 1.999999, and so on, right? So this means, okay, your f of x is not going to be a 2, or not going to cross 2. Okay, similarly here we can say x, let's take, okay, value 1.5 here, all right, and here 1.4, 1.3 tends to 1 means, okay, going to near to 1, 1.2, 1.0, 1.001, 1.00 0.000001, you can say. And you are going to get here 2.5, 2.4, 2.3, 2 point and 2, 2.01, 2.000000, so on. Okay, 1. This means okay, here okay is clear from here, because we have taken value in such a way that x tends to 1. Okay, yeah, freely we can write down x tends to 1. And here again you can say value of x, f of x approaching 2, because firstly 2.5, 2.4, 2.3, 2.2, 2.01, 2.0 is 0, is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, you can say, which is very near to 2, right? Near to 2. And finally we can say here f of it can't be 2, it can't be less than 2, and this means okay, f of x tends to 2. So this is the limit of function. 2 is okay. X may approach from either left side or right side, but uh, okay, you will get one fixed value. Okay, you will get okay one certain number. Okay, certain number to which f of x tends to which f of x approaches. Okay, this certain number, this fixed number, you can say this is your limit of function. Okay, and here symbolically same thing. Okay, we can write down limit, means here limit, this is the symbol for limit, lim, or f of x uh, when x tends to 1 is equal to 2. This is the limit of function. We can write down, we can read limit of function when x tends to 1 is equal to 2. Limit of f of x approaches 2 as x approaches 1. In this way also we can read. All right, I think is clear. Limit intuitive concept of the limit is clear. Actually, we don't use okay this method while doing practices of question, because this method is so lengthy. We have developed okay simple method. Now you can see. I think this by this table okay idea you got okay why now. How we got okay limit of function to here, right? Now same question in short form I can do. So I'm going to tell you limit uh, okay of f of x when x tends to 1 is equal to limit of f of x is x square minus 1 upon x minus 1, x tends to 1. Now see everybody, here x square minus 1 upon x minus 1. uh, Firstly you can put okay, you can, if you put okay, already we have tested, if you want square minus 1 upon 1 minus 1 0 upon 0, so indeterminate form, so you can say okay this is an indeterminate form, 0 upon 0. While finding the limit of function, if you get okay 0 upon 0, this means okay this tells you to simplify the function here, right? So if you get okay, whenever you get indeterminate form means 0 upon 0, infinity minus infinity, or 1 raised to power infinity, um, okay, and so on. And the limit of okay x minus 1 x plus 1, no need to put this bracket, upon x minus 1 as x tends to 1, as x approaches 1, mm, is equal to limit of your x plus 1 as x tends to 1. Now here is a question. If you say why we have simplified here, because okay x approaches 1, but x is not equal to 1, so that's why we can simplify. This is the reason okay to simplify this. Okay, and now you can okay you can limit x tends to 1, this x also tends to 1, right? So instead of this we can add 1 plus, okay, same value we can put, okay, 1 is equal to 2, right? In a long way we got also 2, here also in short way, okay, 2. This is the actual, okay, method we use, okay, this method while finding the limit of function. Okay, I have taken here limit of algebraic function. All right, I think now you understood. And again let me take another example. So let's suppose, okay, limit of 2x plus 3 as x tends to 2. 2x plus 3. Here you are not going to get indeterminate form. So let me tell you hint, okay, indeterminate form. In the beginning of limit, you may get, okay, 0 upon 0 indeterminate form. 0.0, infinity minus infinity, infinity upon infinity, because these are not numbers, these are not any numerical values. That's why you are not going to get, okay, 0 here, you are not going to get here 1. These are indeterminate form, meaningless form. Okay, so these are so in the beginning of the this into the limit of function, okay, you may get, okay, this you can piece, okay, while finding the limit of function in the beginning, 0 upon 0, infinity minus infinity, infinity upon infinity, and gradually you can get equations based on other indeterminate form, 1 raised to power infinity, 0 into infinity, and so on, right? So on. So see here, 0 upon 0, if function is rational, then only you can get, okay, 0 upon 0. All right, and infinity minus infinity, if you are going to find a limit of function as x tends to infinity, then only then you may get, okay, infinity minus infinity. All right, or in some other cases, okay, we may get, especially if we have a function, I think trigonometrical functions, then only. But in case of the algebraic function, so I think, okay, we will not get, okay, infinity minus infinity, right? Infinity minus infinity will get, okay, when you are going to find out the limit of function as x tends to limit, right? So there is no infinity, and the function is here no infinity, x tends to, x approaches infinity. Here simple, okay, polynomial, you can say 2x plus 3 is a polynomial. Here 0, so you can resign, you are not going to get 0 upon 0 because function is not rational function, and there is no infinity, you will not get, okay, infinity minus infinity. All right, and infinity, okay, so these two, okay, at first glance, okay, you can reject, you are not going to get this indeterminate form, this indeterminate form, and here also you are not going to get this one, right? So this means, okay, you are not getting, okay, any indeterminate form. All right, if you are not getting any indeterminate form, then you can put directly 2 instead of x, right? So we can write down 2 times 2 plus 3 here, is going to come 4 plus 3 is equal to 7, right? We can interpret like this way: when x tends to 2, 2x tends to 4, right? And finally 2x plus 3 tends to 7. All right, so 7 is the limit of function, right? So limit of function as x tends to 2, or you can say 2x plus 3 tends to 7 when x tends to 2. So this is all right, everybody. 2x plus 3 tends to 7 when x tends to 2. 2. Okay. Now let's see the okay, here. Now let's move, okay, in noti. So once again, uh, let's conclude all these things, right? A limit of function, here I have written notation. A limit of f of x tends to a is equal to L. So what is L here? Here, okay, limit of, this is your f of x and this is your L, okay, right? F of x, this is your f of x and this is your L, and here, okay, x, and this is your A. Now it will be easy to understand. This is your L, and limit of function as x approaches A is L, you can say. Limit of function, yeah, limit of f of x as x approaches A is L, or you can say the f of x tends to L Or you may say in this way also, f of x tends to L as x tends to a, or when x tends to a. In this way also you can read. All right. So what is the intuitive meaning? Okay, I have explained all intuitive idea, intuitive meaning. So again, okay, summarized. Okay, so let's summarize intuitive idea. We can make f of x as close to L. So very interesting. As close to L means we can make as close to 7. Here 2x plus 3 can be made as close to 7 as desired by closing x sufficiently close to a, means as desired by closing x sufficiently close to 2, right? And x is not equal to a, so definitely here x tends to 2 means x is not equal to 2. Okay. So I think okay, intuitive meaning clear. So once again, let me explain here. Let me again repeat f of x. F of x, okay, here can be made as close as, okay, close to L, right, and as close to L as we wish, right. We wish by making difference between x and a sufficiently small, right. So again, in this is the intuitive meaning. This is a notation of limiter function, and intuitive meaning. Okay, we can make f of x as close to L. Okay, we can make okay f of x sufficiently close to L, right? By making uh, difference between x and a sufficiently small, or we can make okay as close as to L as desired, as we wish, right, by choosing, by making x sufficiently close to a, and x is not equal to a. So graphical interpretation, intuitive idea all are done, notation clear, intuitive meaning also I think clear. Now graphical interpretation, you can say graphically, right? Now see graphical interpretation here. Here I have made okay x-axis and a y-axis. This is the coordinate axis, and this curve represents function y is equal to f of x. Okay, and a function here. Now see, a is a constant here. Let me here is constant. This is a constant, and x is variable. Here okay, x approaches from left of a, and here x approaches a from right of a. All right. So this is a L. Okay, this is a L. Then f of x. Okay, as x approaches from left of a, f of x approaches from left of L, right? And here as okay x approaches from x approaches a from right of a, then f of x approaches L from right of L, right? So see okay, here I have made okay curve from here, so this, and moves okay value this from here to here, and as x approaches a, okay, and as x approaches from here, then okay your this L okay approaches from L approaches from here, right. L approaches okay from firstly here, and then finally here, right. L here, if okay x is here, then if x is here, then L will be here. This mean this line will be L, and this line will be L, and as okay x okay comes here, then L will be this one, and when okay near to a, then your this is near to okay, right. And this represents your limiter function. This circle represents the limiter function, right. We can make okay f of x very close, means as close as to L as desired by choosing x sufficiently small. From here also same thing, same way we can say f of x as close to L as desired by choosing x sufficiently small. So you can move from either side, but you will get okay f of x very close to L. All right, this is the graphical interpretation. I think it's clear, and intuitive meaning clear, notation clear. I have discussed okay some questions also. some only just to get into questions I will take it. How to find out the limit of function. Okay, now I will tell you. I will solve here some easy questions. How to find out the limit of that type of questions. All right. Okay. So let's move into the questions. All right. Before doing questions of limit, I have taken okay, very dead simple questions. I will tell you how to evaluate the limit problems. How these are very dead simple questions. Okay, uh, gradually we will do difficult questions. Limit theorem. Before doing okay, let's discuss the limit theorems. Let f of x and g of x be two functions of x such that limit of f of x as x tends to a l. Let's suppose limit of g of x is equal to is m as x tends to a. Then we have following theorems. Number one. Limit of f of x plus minus g of x as x tends to a is equal to limit of f of x as x tends to a plus minus limit of g of x tends to a. And second one, limit of f of x into g of x as x tends to a, limit of f of x as x tends to a into limit of g of x as x tends to a. And third one, limit of f of x over g of x as x tends to a is equal to limit of f of x as x tends to a over limit of g of x as x tends to a is equal to L upon m. If limit of g of x as x tends to a not equal to 0, limit of f of x inside the radical sign, limit of nth root of f of x as x tends to a is equal to nth root of limit of f of x as x tends to a. We can write down like this way, is equal to nth root of L. Okay. So see, so what is the meaning of this one here? If they are okay, functions are separated by okay plus minus, uh, but we are going to calculate the limit. We can find out we can evaluate limit okay separately. We can write down separately, and here also in case of product also we can write down separately, yeah, in this form okay, let's say. And here also we can write down okay separately. Here we can take okay whole nth root, right? Let me explain with example. If we have suppose okay limit here, limit f of a, according to the first theorem we can write down okay limit, suppose here 2x square plus 3x, right? And here plus minus x tends to 2. You can write down also like this way, x tends to here to 2x square plus minus limit of 3x x tends to a. Meaning of this one you can write down like this way also, or either you can find out okay as okay as a one function, or you can find out okay by making two functions, right? Limit of two functions. Okay, you can we can write down this. And so according to the second also, if we have a function okay limit of suppose here okay or 2x plus 3 into 2x minus 5 here as x tends to 1, we can write down okay just I'm telling how can we use this second theorem. We can write down 2x plus 3 into limit of 2x minus 5 as x tends to 1. We have 5. Okay, so I think this is also clear. Similarly, in this case also we can write down, but limit of g of x as x tends to a should not be equal to 0. Okay, should be not equal to 0. Then only we can apply okay this form. Otherwise we can't. Okay. Here also we can write down nth root of f of x. We can take nth root of f of limit of f of x as x tends to a. All right. So we can use these theorems while evaluating, while we evaluate the limit of function. Okay. So let's move how to find out the limit of function. Limit of function. First question. Solution. Limit of 4x minus 5 upon 2x plus 4 as x tends to 3. First of all, you will check. You will check whether you are getting indeterminate form or not. How to check, okay, whether we are getting indeterminate form or not? So directly you can put, okay, 3 instead of x. You can substitute 3, okay, you can substitute the value of x, okay, as a 3, okay, let's suppose. Here, 4, if you put, okay, 4 into 3 minus 5, 2 into 3 plus 4, 12 minus 7, and you are not going to get, okay, here, not going to get, okay, 0, 0 or any other indeterminate form. All right. So this is not in indeterminate form. So if your function is not in indeterminate form, then you can use, okay, directly 3 uh, as you find out the value of function. 4 into 3 minus 5 upon 2 into 3 plus 4, right? We can interpret like this way. When x tends to 3, then 4x tends to 12, and minus 5 upon when x tends to 3, then 2x tends to 6 plus 4, right? And 7 upon 12 minus, so 10. This is the limit of function, right? Limit of function. And one more thing, always you will get constant number, right? Constant limit of function. Constant number will be the limit of function, right? So some students find the limit of function in terms of variable. So please don't find out in terms of x. If you are finding, okay, if you are getting in terms of, this means, okay, you are wrong. Surely you are wrong somewhere. Now second limit x, okay, here, limit of x square plus 4x upon x as x tends to 0 is equal to here when we check, okay, here 0 0 0, so here you are going to get, okay, form 0 upon 0. This means this is an indeterminate form. So as I told you, okay, if function is an indeterminate form, firstly you have to remove indeterminate form. So how to remove the indeterminate form? By simplifying the function. Let's simplify. X common, here we can x common, 3x plus 4 upon x, and as x tends to 0, x, okay, going to be cancelled out. A limit x tends to 0, you will write down 3x plus 4, right? Okay. Now this is not an indeterminate form. You can say 3x tends to 0 when x tends to 0, and 3x tends to 0 plus 4, and so finally 4 is the limit of function. This is the limit of function. So I think clear. And then so you have no problem how to find out here limit of function. Now third one, limit of 4x cube minus x square plus 2x upon 3x square plus 4x as x tends to 0. If you see here, x means, okay, 0 0 0 0 0, so definitely you're gonna get, okay, 0 upon 0 means indeterminate form. So again it tells you need to simplify. Okay, so simplification only. First step, common. Here x common, 4 x squared minus x plus 2 upon here x 3x plus 4. Alright, as x tends to 0, x cancel out, and after cancelling out x term, you are going to get 4x minus x plus 2 upon 3x plus 4. Now I think, oh yeah, this is not in indeterminate form, 0, 0 and 0 here for no. Now okay, 4x square. When x tends to 0, 4x square tends to 0 minus x tends to 0 and plus 2 upon 3x tends to 0 plus 4 and 2 upon 4 is equal to 1 upon 2. This is the limit of function. Okay. And let's see the question number 4. Your limit x tends to 4, x cube minus 64, limit of x cube minus 64 over x square minus 16 as x tends to 4. As x tends to 4, x cube tends to 64, and as x square tends to as x tends to 4, x square tends to 4. 16. So 64 minus 16, 0, 0 upon 0. So you can say 0 upon 0 form, which is in indeterminate form. Indeterminate form means you need to simplify. So let's simplify. We can write down x cube minus 4 cube and x square minus 4 square is 0. Yes, in earlier classes, I think you might have studied a cube minus b cube. Limit x tends to 4, right down here. A cube and x minus 4 and x square plus 4x plus 16 upon x minus 4, x plus 4. Here, a cube minus b cube formula I have used, a minus b in factorization form, a square plus ab plus b square. And the second one, a square minus b square formula means a minus b, a plus b. Okay. Definitely you have studied in earlier class. Okay, here cancel, and you are going to get x square plus 4x plus 16 upon x plus 4. Now you can check again. X tends to 4, alright, 16, 4x tends to 16 and x. Okay, now okay, you are not going to get here 0 upon 0. Now it is not in indeterminate form. So I'm going to explain here. Now remaining part here, all limit is equal to, okay, no need to write down. Now we can find out x squared tends to 16, 4x tends to 16 plus 16 upon x tends to 4 plus 4 and 48 upon 8. So I think it goes by 6. So 6 is the limit of function. This way we can find out, right? So in which case limit of function does not exist. So whenever you get, okay, infinity, at the time we can say limit does not exist. Later we will discuss, okay, when we'll study left hand limit, right hand limit. At that time also we have, okay, when left hand limit is not equal to right hand limit. At that time also we can we can say limit of function does not exist, right? Later we'll discuss about the right hand limit and left hand limit. But while finding the limit of function, in this case, if you get infinity, you can say limit of function does not exist. But okay, limit of function, okay, never comes in the in this form, 0 upon 0, 0, or infinity minus infinity, infinity upon infinity. These are indeterminate forms. Again and again I am telling you all, okay, if you are getting, okay, in this form, this means, okay, you have to simplify the function further. Okay, clear. Now 5 number question. All right. Now you can see how to uh, evaluate limit x tends to 2. Here x square minus 5x plus 6 upon x square minus x minus 2 is equal to, okay, you have to check firstly. X square tends to 4, 5x tends to 10, 4 plus 6 10, 10 minus 10 0, and x square tends to 4, x tends to 2 means minus 2 minus 2 minus 2 minus 4, 4 minus 4 0, so you have 0 upon 0. In this question we have factorized numerator and denominator. Here common x common, here also x common. In this way we simplified. Now here this is a trinomial, this is a trinomial. Here also this is in the form of a square ax square plus bx plus c. This means we have to split the middle term. This way we can factorize, right? So alright, so let's see. X square minus 3x minus 2x plus 6. You know this x square minus 2x plus 6 minus 2. How to simplify, how to split middle term? Product 6 and sum is minus 5. So this way we have to break. Okay, 6. 3 to the 6 and 3 plus 2 5. Okay, minus 5, right? Minus 3 minus 2 minus 5. Minus 3 into minus 2 by 6. Here also product is minus 2 and sum is minus 1. So minus 2 into plus 1, minus 2 plus 1 minus 1. So satisfied. Okay, you have studied in lower classes. Very well. X common. So from first and last two, x common, x minus 3, and here minus 2 common, x minus 3. Here x common, x minus 2 plus 1 common, x minus 2 is equal to limit x tends to 2. Again x minus 3 common, inside the bracket you're gonna get x minus 2 and x minus 2 common again from denominator, and inside the bracket we have x plus 1. Okay, yeah, x minus 2 going to be cancelled out. You are getting here x minus 3, x plus 1. Now so this is not in indeterminate form. X tends to 2 minus 3 and x tends to 2 plus 1 and minus 2 upon 3. This is the limiter function. Okay, so I think now you understood how to find out the limit of simple algebraic functions, right? These are that simple questions. I think you got enough idea how to crack down these type of questions. And there is a one more question 6 I have left for you, so try, and if you are interested you can see from different books and go through firstly simple question. If you are okay new one, if you are okay beginner, so definitely I have made this video for the students who are going to just learn limiter function, who are going to get the idea, who want to get the idea of a limiter function. So they must try, they must try, they must try. I have taken, yes, so I have left for you for practice. You can find out the limit of this function, and you can take through the different books, simple, firstly try practice with the simple questions, and then definitely we will try to find out the limit of harder questions. Okay, see you. And but one more thing, let me tell you again, many times I say, subscribe, you will be benefited definitely. Subscribe and more, subscribe and share to your friends who want to learn limiter function. Bye, see you till next video. Bye.